Hello everyone and welcome to my channel #analytics. For this demonstration, I will be showing you on how to code a decision tree. We will be using this Jupyter notebook for us to write our Python code. So we will be using this data. So I have here my data. The name of my data is, or my data sets is academics.csv, and the contents of my data sets are NCHI attributes, English, Math, Science, and Performance. These are the attributes of my data set. So we will be using this, okay, to build a decision tree. But since I have here an attribute NCHI column, so we will not be using this one. We will only use the English, the Math, the Science. And we have a total of how many rows do we have? So we have 133 rows because we start from 1. And based on the grades of this subject, English, Math, and Science, so the remarks here for the academic performance is capable. So this is based on the range, okay, used to determine if this particular grade is capable, competent, and challenge. So we have three categories here, and this is our target. So we will be using this. So we will be doing a prediction. So if we're going to input some values, then it will predict. But of course, before doing that, we have to code this in Python. Okay, so let's start working our Python. So I'm using a Jupyter notebook. So since we're working with tabular rows and columns, so we need this library, pandas. Then we name this library as PD. Then we will be also using a numpy for our array, because we will generate an array here later. Okay, then we will use the sklearn library, the matrix. We will be we'll be looking at the accuracy and the confusion matrix of the decision tree. So we'll be using metrics here. Okay, then we import the class accuracy score and the confusion matrix. Okay, confusion matrix. So these are the matrix that we're going to apply in our decision tree. So also we are going to import the class train test split, because we will be using that test, okay, and check the prediction, of course. So we need import. We need to make a train test split class. We will use this one because we're going to split our data. Later, we will be splitting our data. 80% is our training data sets, and 20% would be our testing data sets. So this particular part, so this is the class for the splitting of our data. Okay, so we have 133, okay, number of rows. So 80% of that would be our training data sets, and the 20% would be our testing data sets. Okay, then of course, we are going to use our decision tree classifier. So we will access that from the sklearn tree. Then we import the class, which is the decision tree classifier. Okay, so since we have already our libraries, these are the libraries that we're going to apply later. So again, we'll make a comment for this. So this is your libraries for you to manipulate your tabular data in rows and columns. Data in rows and columns, and we'll use that for us to read the academics file that I showed you a while ago. I have the Excel file, the CSV file, so we will use the pandas for that, for us to, for the, okay, Python to read our CSV file, and this is for the array, okay. Then this is the measurement to check if our model, okay, check the accuracy score of our model, decision tree model. So this is to check the accuracy score of our model. It's important to check the accuracy score and the confusion matrix, of course, along with the confusion matrix. Then this is the train test, splitting the data. Then this is our decision tree class. We'll use that to split the tree, okay, and build the tree. So use to split the data, okay. So this is a decision tree classifier. So we are building the tree, building the tree. In the decision tree, of course, if you manually compute that, so you have to compute the entropy. So after the entropy, you have to compute the Shannon's formula, okay? Then for you to compute the information gain. So from that column that we have in our data sets, so it will identify the English and Math Science, which this particular attribute is the root node. Okay, and this is our target. Now let's run this one. So okay, so I think I have an error here at this part. So then run. So we don't have now an error. So let's proceed to our we need to read. No, there's another error. Decision tree classifier. Oh, it's wrong spelling. Then run. Okay, I think there's no error. Then now we are going to read our CSV file. If you remember, the name of the CSV file that we have is academic.csv. Okay, then we have to go back to our Python, and we have to assign variable for that data example, and PD is the variable for our pandas that allows us to manipulate rows and columns. Then we read our CSV. So the function inside the parameter is the file name of our Excel file. Okay, then try to run it. So if you want to view, since this academic.csv is already stored in this variable, so we can now show or display our CSV in this using this code head. Then we run it, so we can display our data frame for this code. So there we have it. So as you can see, so this is the same with our Excel. So therefore, Python read our CSV file. Okay. Then after that, we have to check, of course, if you want to check your columns. So just type columns data. So the data is now the variable that holds our CSV file, the academic.csv file. So let's run this ones, and these are the column attribute. Okay, then after that, we can, of course, display our data frame, and let's check how many rows and columns do we have. So by typing this shape, data.shape, when you use that, so you can now display, you can now identify the number of rows and columns in your CSV file. So therefore, we have 133 and 5 columns. So if you want to go back to your CSV file, so we have 1, 2, 3, 4, 5. So we have 5 columns, and the total is 134, but since we started with number 2, so it's 133. Okay, going back to our Python, then after that, we need to do the data cleaning. Why? Because I have said earlier that we will not include this one. So we have to remove this column. So what we're going to do to remove this column is we have to access our data where we store our CSV file. Then we have to make a condition if it is a data is contains null in any of the row, then access starting the one, then that head. So let's, of course, including the head of the data frame. Then let's try to run. So this particular code allow us to view the null value. When we say null, so meaning there's an empty values in our Excel. So let's try our CSV file. Sorry. So what happened? So we have, I think, this one I have. Okay. So I mistakenly positioned my square bracket. It should be placed here. Okay, then run. And now there we have, okay, as you can see, so none, this is our null value. So position in index 5, 8, and 19. So let's check if that is correct based on our, okay, here. So that's 5, right? 1, 2, 3, 4. I will start from 0, of course. Array. So 0, 1, 2, 3, 4, 5. So then 6, 7, 8, and so on. So let's go back. So that's the reason why. So this is indicate the index, and index start with 0. Okay, so there's a null value. So we're going to remove this nchi column. So to remove our nchi column, we're going to use the delete, then data. Then in our bracket, we have to, of course, type the attribute that you want to delete. Okay, and chi. So which means we're going to delete from our data frame the nchi column. Okay, so this is how to delete it. Then making sure single quote here. Okay, so then run. Then we have to drop this. Okay, do the drop. Okay, from our data, still the data itself. Then the data is now the variable where we store our data frame. Then drop, not then run. And to check it out, okay, if we have 5 columns, so we have to check it by looking at the shape of our data frame. So we have 133 rows, and we have 4 what do you call this 4 columns. Okay, if you want to check if we already deleted the the column. So all you have to do is just type head, then run. Okay, so as you can see, we don't have now the the NCHI column. Then we will store this new data, so to a new variable. Okay, so to do that, of course, we have to create a variable. Let's say this is our clean data. Okay, our clean data. We will store this new data frame into a new variable. So from the data, that's the original name of our data frame, then copy. So this will be copy to this variable. Okay, then run. Then you can check the clean data now. So we have the new variable now. So clean data here, then run. So we will use that, then run. So we have now here our clean data. Okay, so the new variable for our data frame is clean data. Then after that, we need to identify our x. So when you say x variables, so this are our x values. So the English, the math, and the science. And this is our y. Okay, so this is the prediction. Okay, the y. This is our predictors, our values. No? Then we're going to store that in an x variable. Then the new the new variable is clean data. Okay, so the new variable now is the clean data. We change the variable clean data. Then data, then in this location, okay, the array is a 0, then 0 1 0, this is 0, then -1, which means that in our x we will not include this one. Okay, so it's -1, so we'll not include this part, this performance column for this. So we will store the English, the math, the science column to the x. Okay, then we also store our y, which is our the target variable, the indices location, then of course in this location, then also 0 0 0, and this is 0 1 2 3. So meaning we have to so 3, so to check it out if we correctly store the values of x of this one to x and this particular performance to y. So all you have to do is run that, and you have to run your x value to really check if we store it correctly. So we store it correctly, so meaning English, math, and science is already stored in the x value. Then let's try to check if this code is correct if we only store this performance attribute, in our y value. So just type y, then run. So we only store the target. So we are correct in this code. Okay, identifying the location. Now we're going to uh, make our testing data set. So we need to, since we have already imported our train test split library here, so we are using this one to the next code that I'm going to show to you. So all you have to do is you need to type the X train, the 30%, the 20%, then X and test, meaning we have 133. So when we calculate that, okay, calculator, so which means if you have 133 times 0.20, so that's our testing data set. So we're going to have 27, okay, values. So the rest are in our training data sets. Then our training data sets is if we have 27 minus 133, so which means that we have 106 in our training data sets. So this is 106 and this is 27 for our x values. And for our y, of course, 106 for this and our y test variable. So then we have here our class. So we need to split our data to x. We have x and y. Then we test the size. As I've said, 20%, so 0.20. So then we pick it randomly from 133. We pick the testing data sets, which is 27, as we computed a while ago, then 0. We start from 0 there. Then we run this one, run. Okay, then now we will fit that. So since we have already split our data to 80% of 133 and 20% of 130. So 80% is 106 and we have 27 for our testing data sets. So as we declare here are 20%. Then we need to fit our training model and our testing. So we need to fit that. So all you have to do is to type. Of course, you need a variable, but before we fit that, we have to store our decision tree classifier object, so to a variable. So example, our variable is regressor, then this is our classifier. So after we split our data, then we now apply our decision tree classifier object, and that object will be stored in this variable. Then run. Then now we will fit our since we store our decision tree classifier object to regressor, so we need to fit our x and y value. So regressor fit. So we have already split our data and now we need to fit that. Okay, then this is a variable of inside the fit is our parameter, our training. So we need meaning the 80% of 133 is now already fit in our decision tree classifier. Okay, then run. Oh, this there regressor. Sorry for that. Regressor. Then run. Okay, so we have already fit. So we have built our training data sets, and now we are going to. Okay, so of course, in a decision tree classifier, we need to identify when to stop our tree. So for this demonstration, let's say we're going to stop our tree. For example, is we need to, of course, our variable for our decision tree is regressor. Then decision tree classifier. Okay, classifier. So we have to, okay, have this leap nodes, and our parameter is equal to 5. Then we random that associate with 0. Okay, So meaning if there's a 5 values, so then we will stop our, okay, our 3 to expand. Okay, that's the purpose of that. Then we need to do the prediction of our X test, but we have to run this first run. Okay, so next is we have to create a prediction. So we will predict the X value. So we have to type, since our decision tree is stored in this variable, then we now predict our X test. So X test is our English, math, and science. Okay, then we will store that in a new variable. Okay, variable y sample predicted. Okay, then let's try to check. So we check our X test, then run. We have what happened? Call fit estimator. Okay, I forgot to have before this we need to fit. Okay, because we have already do some we do some leaf node here, so we need to fit our decision tree model. Okay, so all you have to do is, of course, this is the variable, then we have to fit it because this is a new thing. If you check, we do the fitting here when we build our 80% and 20%. So meaning 20% is our testing data sets and we fit that. So we put it in our decision classifier, but we add some parameters here. The leap node is equals to 5. So this is our control, okay, to stop the tree. So we need to fit it again. Okay, so fit it again, our train model, X trained, or our training data set. So Y train. Okay, so that's how you feed, then run. Then before you run this part, okay, then run. Okay, so it's now accepted. Now, since we have already fit the decision tree and we have limit it to maximum leaf node of 5, so we will check the accuracy score. So accuracy score, where we get this one, we import this class from the sklearn matrix, okay, to evaluate our model. Then y test is and y predicted, okay, predicted. So we have here the y predicted here is we have already established that y there, the predicted here. So y predicted for the X test. Okay, then when we multiply that to get the accuracy to 100. So we have the Y test, we have 20% and predicted of our X test here, then run. So meaning we have 96.29% accuracy of our decision tree model. And this is a good model. So we have 96. So, and for you to draw the confusion matrix, so you have to type the class confusion matrix. The function inside is, of course, your Y test and your Y predicted. Okay, the Y predicted of your X value, because there are predictors from the X values, then you have to run it. Then there we have it. Okay, so this is a confusion matrix. So the accuracy score is 96, and that is a good model. And after that, we need to test the values. Okay, we'll try to test the values. So all we have to do, since we have already try to check if we go directly to the test the value. For example, we will test the value. We have, since that the values are stored in an array, so we have to call out our NP, the numpy. Okay, then array. Then let's try to check if we're going to feed a new value. Then let's check how it predicts not. If that is competent, if this value, since we have three attributes, so English, math, so assuming this is now the new value to feed in English, then this is the math, for example. Then this is now the science, for example. So we will test these values, no, to our trained data sets and what is the prediction, to know what is the prediction. Okay, then of course we have to store that in our new variables, like for example, so we use another values variables for this. So x value, x new value. Okay, x new value. Okay, then we need to do some prediction, then run. Then we have to check the regressor. Our regressor is, remember, that is our decision tree. Then predict. Then inside the parameter is the x, the new value. Okay, new val. Okay, then we will store that into our y prediction. Y uh, okay, prediction. Y pred. So we have a new variable for this. Okay, so why we have a new variable? So this is a new value, and we're going to store that in a new variable. So in a previous variables that we have is y predicted, okay, because we're going to test the training data sets. But here, this is a new value, okay. This is not belong to the existing data sets. This is a new value, so we need to store that in a new variable. Then we have to run it, then try how our, what's the prediction? Of course, y, let's check the prediction. What's the result? Okay, so then run. So meaning it is challenge. So therefore, this particular values belong to challenge. What if we change this to 94? And this is 94. Okay, let's see. Then we have to run it again, then run, then run. Okay, now we change our target variable, and it says that these values, okay, this is English, math, and science, so belongs to competent. What if we're going to change to 85, 84, 85, 85, and 86? So let's see what happened, because we have three categories, if you remember, in our data set. Then run, then run, and run it, and this is relative capable. So where they get this one, of course, we do the classification using the decision tree, and based on our, of course, data set. So 80% of this is our data sets, and the 20% is our testing data sets. So, and we check the accuracy, and the model is good because we have generated 96.29 accuracy of our model, our decision tree model. Okay, so before I end this demonstration, I will review again the code. Okay, so this is the library. So the purpose of this pandas is for us to manipulate the data, and we will assign the library to a variable PD. So we will use the PD instead of the word pandas, because this is the variable now for the pandas library. And we will use this in our CSV file. So using the PD, we can read our CSV file. This is particular, this library is to generate the array, read an array, then we assign a variable NP. So as I've said, you can change your variable assignment. And this is the sklearn, okay, in sklearn, so we can access, of course, the matrix. Then we use the class to check the accuracy of our model and the confusion matrix. And we need also the model selection, okay, because we need to split our data. We split our data, 80% is our training data sets, and 20% is our testing data sets. Okay, so the testing data sets, okay, will be used to test our training data sets accuracy. So we need to split our data. Then this one is our decision tree classifier class that allows to split the data. And after declaring all the libraries that we need, is we have to check if we read our CSV file. So where did I get this one? Because I have an Excel file. The name is CSV. Okay, so we will access that and it contains five attributes: the NCHI, the English, the math, science, and performance. And for this demonstration, we will be removing this part, the NCHI, later. So we will use these three subjects and the performance. Then the columns, if you want to know the columns, so this is the code that you're going to type for you to display that these are the attributes that you have in your data frame. Then if you want to really know your the number of rows and number of columns, so all you have to do is to type this, call out the shape. The data is now the new name of our CSV file. Okay, so we store that, right? Remember to a variable data. You can change this, okay, to any variable that you want. Then, of course, we do the cleaning of the data. So why we do the cleaning is to really check if there are rows and columns that has no values in our Excel. So there are some rows that there's no value. So Python can also check that by typing this, okay? Of course, this code, okay, inside our square bracket is we have to check if there's a null value in any of the rows. Then, of course, with the head, of course, this one. Then, as you can see, so it will display automatically the rows that contains or the indices, okay, that contains the null value. So again, how to identify this? Well, it's 5, 8, and 19. So our array start with a 0. Okay, when we go to our Excel, so this is 0, 1, 2, 3, 4, 5. So meaning our null value is positioned at index 5, 6, 7, 8. There we have also 8. And 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this go back to our Python code. So this is now the indices if you want to check, and this, of course, the null value. Okay, and since I am not going to use this column, so I will delete this NCHI column. So to do that is I have to type the del, then delete, or of course from the variable where we store our academic.csv file, then we have to delete a particular column. So you have to check how do you write your attributes is still the same here. For you to delete this part, then you have to drop that, okay, and we still use the variable data since we dropped this one. So we have a new transformation of our data frame. So you can change this variable if you want, but we will not change that. Still, we will use data. So now we have a new transformation um, of our data frame. Then to check that, so we have to type this one if we really remove this part. As you can see, we have already still 133 columns, rows, and we have 4 columns. So meaning there are 4 columns left. Our original data frame 1, 2, 3, 4, 5. So 5, and now we have 4 because we have already dropped this column and chi. And to really check if we really drop this, then we have to run our data since we still use the data a variable for our CSV, our data frame. Now we did not see anymore the NCHI column. Then we have to copy this because we did a transformation of our data. So data.copy, and we store that to the new variable. That's our clean data. And to really check if we transfer that into the new variable, then we type this one and display that. So we have 103 columns by 4 columns. And now we need to identify these variables or attributes, our x values. So for this demonstration, of course, our x values composed of English, math, and science. And we need to store this into a new variable. And this one is our y values. We have also to store this in another variable. So that's the reason why we have this code. So this particular code is for you to store the x values because we need to identify the x values from our data sets or data frame. So these are the x value, the English, the math, and the science. So we will store that. So 0 to -1, meaning this will not be included here. Okay, then we will store that in our x values. And for our y value, we need to know the position of our y value. And to know the position, of course, our array starts with 0. So if this is 0, 1, 2, 3. So meaning we position our y value in this column. So to really check if we did the correct thing, all you have to do is to type the x. And it will show you that we have stored the x values, English, math, and science. And for the y value, we stored performance. So we did a correct code for this positioning of our x values to a particular location. And now we're going to do the splitting of our data. So since we have already imported library, if you are going back to our library declaration, so we have already declared our class train test split. So why we split our data? We split our data. Okay, as you can see here, okay, our x values are x train and x test. So which means we have 133 rows. 80% of that values 133. That's 80% of 133 is 106. So that would be our x trained, and the 27 or the 20% is our x test. So the x values are composed of the English, math, and science. And for our y train, of course, the values that we can check in our y train are the performance, the capable, competent, and the challenge. So the 80% of that, which is 106, and this one y test is our, of course, 20% testing data sets. So we store, of course, we store our splitting of the data of 20% because this is our class and the function of train test split, okay, that's composed of x and y. So the test size is 20%, so therefore uh, we have 80% training data sets, which will be stored in this variables, okay? And we randomly pick the 20%, okay, equal to 0. So since we have already split the data, now we import our decision tree classifier. So for our decision tree classifier or object, we need to store that in another variable. We use a regressor variable, but you can change this variable because this is just a variable. So it's up to you. It's up to you if you change the variable. So this is the object. And since we have already split the data, from the original data, we did not split that. And now, since we split the data, we need to fit that data. Okay, so since we need to fit the data, the X train and our Y train, okay, we need to fit that. So meaning 80%. So that's our training data sets. Okay, so we have now our decision tree classifier for that. But in decision tree, we have also to identify when to stop the data. So in this decision tree classifier, I just have here 5, okay, a leaf node of 5. So if there's a 5, okay, values in that splitting the data, then we will stop our decision tree. And of course, since we did a new mechanism for our decision tree, not like this part, so we did not did a leaf node here. We just let our tree to grow. But in this part, so we need to control our tree, and we have a value of 5. So then we store that in a new variable, and we need to fit it again. Okay, so this is the new transformation of our data. Why there's a new transformation? Because if you check on this, we have already fit our data in this part. This is 80% or 20%. But since we add additional parameters, so we need to fit our data, okay, again. Then since we have already fit the data, okay, we control our decision tree. Then now we will going to predict our X values or X test. No, then we store that in the new variable. Okay, then now we will check the accuracy of our model. So let's check, okay, the accuracy by using this class accuracy score. And the parameter inside the accuracy score is your Y test. The 30% and the Y predicted, okay, then multiplied by 100. So when we run this one, then we generate 96.29 accuracy score, and this is a good model. And you can also generate your confusion matrix, okay, to show you the classification. This is the confusion matrix, okay, and for you to really test, now we will be testing our model if we're going to input some new values. This value is outside, of course. This is a new value to be fed in our decision tree model. So let's try to check since we have 96.29% accuracy score. So let's say we have 84 English and 85 math, science is 86. Then since this value is stored in an array, as you can see here, or stored in an array, then we use the variable np. np is the numpy library. Okay, so for us to access the array, now we will store that. Since we test a new value, we will store that in a new variable. So this is a new variable. Then we will predict. Okay, so our decision tree is now the name is aggressor. Then the prediction, okay, of our new value, that 84, 85, and 86. Then we will store that to our Y prediction. So Y prediction are contains with performance remarks of competent, capable, and challenge. So we have already stored that. Then now let's run. What's the prediction of this value? So the prediction of this value that we inputted is belongs to capable. So if we want to change, then change that one. Okay, this is the actual application of our decision tree model. Once we already built our decision tree, then you can test now your decision tree and you can check the outcomes of your decision tree. Then you have to run this one, run, and run. Okay, so that's competent. Okay, that's all. I hope that you learned this demonstration. This is just initial start of a decision tree. You can add more functionality of your decision tree. And that's all. Thank you for watching my YouTube channel, #analytics.